Adapt N is basically a computational tool that's in the so-called cloud that allows farmers to generate better recommendations for nitrogen rates based on information related to weather especially, as well as soils and the crop management. And they can monitor the nitrogen status of their field throughout a growing season, and at the time when they need to make a decision on how much nitrogen to apply, they can use the tool and develop an optimum nitrogen rate recommendation for their corn crop.
I'm a corn and soybean farmer in southern Kewah County. I raise about 1,000 acres of corn and about 400 acres of soybeans every year, depending on the rotation of the fields. Well, I guess the cost saving to us is probably the biggest benefit. And of course, the operation goes faster because you can go farther before you have to refill the tank on the applicator, and that's another benefit of sorts. But the big benefit is the price of using less nitrogen, I should say.
Corn is the focus of Adapt N for a couple of reasons. One, it is the crop that receives most of the nitrogen, not only because we have a lot of acres of corn in the United States, but also because we apply a lot of nitrogen onto the corn. In addition, corn is the crop that is most sensitive to weather when it comes to determining the optimum nitrogen rate. And that has to do with the fact that corn is basically a tropical crop that we grow in temperate regions, and so there's a significant period in the early part of the growing season when the corn crop is still relatively small, when it's very sensitive to nitrogen losses if we say get a 2-inch or a 3-inch rainfall event.
Before Adapt N was developed, there is a formula that was developed 25 or 30 years ago by faculty here in this department or section that was based on work that they had done at our research farms for providing nitrogen recommendations. And it was a very simple formula that did not explicitly account for the impacts of weather. So the real step forward that we did was to explicitly account for the impacts of weather in collaboration with the Northeast Regional Climate Center in developing this Adapt N tool.
The Northeast Regional Climate Center has been a partner with NOAA for almost 30 years. We operate under a contract with NOAA, and our mission is to facilitate the dissemination of climate data and climate data products to users in a variety of sectors. And one of the things that we knew we were going to need very early on is weather data at a fairly high spatial resolution. So it was our role to take NOAA climate data and develop an interpolated daily product that could feed into the models that Adapt N required. One criteria that Adapt N really wanted to rely on was observed ground truth station data. So really the GHCN daily is the go-to data set for daily data for the majority of stations across the country. We can grab data on a daily basis, maybe on the order of 5,000, 6,000, 7,000 stations report to us each day. In the archive, there's even more stations than that in the GHCN. So really it gives us the station density that we need to run the interpolations that we need for the model. The other thing was the frequency at which we can get the data. We have real-time feeds to that data, so we can get that data to start off with first thing in the morning when the farmers need that data and we need to input it into the Adapt N tool. But more importantly, as time went on, we could grab that data from the NCEI archive to make sure that the data were of the quality that the developers of Adapt N were desired in their product.
Today, Adapt N is available in 28 states. That starts in the Northeast, goes west out to the Dakotas through Nebraska, and then basically draws a line down into the Carolinas. We're looking to expand that to an additional 8 states next season and hope to eventually expand internationally as well. Today, the 28 states we cover represents about 95% of the corn acres in the U.S. So even though it's not most of the country geographically, we are covering most of the corn that's grown in the U.S., but we'll look to expand that as much as we can.